Hi everybody, this is your video for Tuesday, October 22nd. We are just going to go through, I'm going to have you get your notes out and just double check, first of all, that you have what I have on your notes. And then just to kind of set the stage, we did just a really quick hands-on activity with some Airhead candies today. And let me kind of describe that. So I had one of the small little mini bars of the Airheads, and I had one person at each table put that in a pocket or in between their leg and the chair somewhere where it was going to transfer their body heat to the Airhead. I don't want them to do anything with it yet, just hang tight, and then we'll come back and talk about that in a second. We're going to use it as a model. All right, so I just started class by asking if anybody had any questions about the crust. So if you have any questions, just send me an email and I'll try and clarify those. We reviewed our three concepts today. Earth's outer layer is made of hard solid rock. It's divided into sections called plates, and those plates move. All right, I'm going to skip that one. We're going to start talking about the mantle. So on your notes, you're going to look at the section for mantle. And the mantle, of course, is the layer of earth between the crust and the core. And so I've got it marked there in between the yellow brackets. This area is called the mantle. So in your notes, this page is the first three lines. And each of the red words is one blank. So the very first sentence you should have is the mantle is much thicker than the crust and contains most of the Earth's mass. And the mantle is the mantle is the Earth's thickest layer. So I'll stop the video and finish writing all that stuff in and then continue. I'm just going to go ahead and talk as if I'm just talking. I won't pause or anything, so if you need to stop the video so that you can write things down, go ahead and do that and start it again. So the mantle is much thicker than the crust. It contains most of the Earth's mass. What does that mean? Remember, mass is the amount of matter in an object. So that means in the mantle, most of the Earth's matter or atoms, stuff that make up the Earth, it's located in the mantle. So we talked real quickly about what does that mean for density. Remember, density is the ratio between mass and volume. Not ratio, it's the total mass divided by the total volume. We talked just real quick about mass and volume. Mass is the amount of matter in an object. The volume is how much space that takes up. And so we just kind of did a little prediction here. If the crust is it contains less than 1% of the mass of the entire Earth, and it takes up less than 1% of space, we know that that is really not very dense at all, and that's what we talked about yesterday in the notes. Looking at the mantle and the core, I want you to predict which one you think is more dense. Is the mantle more dense or is the core more dense? All right, we'll come back to that in a second. So the molten rock, the mantle is made completely of molten rock. And what does that word molten mean? So molten is from the Latin word for melted. And we talked a little bit in class about what does that mean. A lot of times people think of the word melted and they think of something like water, ice that is totally melted. And then you have this liquid or butter that's melted. And it's a really runny liquid. But remember, melted rock is not runny like a liquid. It's still fairly solid. It is called a semi-soft rock. So the next sentence you have in your notes will be semi-soft. And then the next blank is rock. And if you remember, this is the peanut butter model. If you remember the video, there was a geologist that poured honey on top of rock, and then she poured peanut butter on top of a rock. And the magma that is made up, the mantle is made up of this melted molten rock, and it can have the consistency of honey, where it's closer to the Earth's surface or to the heat source, and it has very it's easy to pour, or it can have the consistency of like warmer peanut butter. It does flow, but it's a thick, sticky substance that flows. So we used another food item to help us understand how the crust is made of hard solid rock and the mantle is made of soft solid rock. We used those airheads. So here's what we did. Let me describe it. In class, I gave the kids another different bar that had been frozen. And then they compared that to the one that they had in their pocket. And so we could see that if we're using this as a model, the frozen airhead is like the crust. It's hard, solid, brittle. It breaks apart. The kids even took them and dropped them. You know, they were standing up and they kind of dropped them onto the floor and they just broke apart. Random pieces, jagged pieces, they just broke apart. But the part that they had closest to their body heat, they just held it and it just bent down. It was really soft. It bent easily. And we use the word plastic because that means that it's able to change shape easily. And the more they worked with it, the cooler it got, right? And so then it became kind of harder again, not as hard as when it was frozen, but it was a good lesson to understand the whole idea of cooling and hardening and getting close to a heat source and warming up. I want you to take a screenshot of this and you're going to put it in your digital notes. There's a space to the right of the mantle information. You just have some white space there, and I want you to take a picture of this and put it in there. All right, so next on your notes, the mantle is denser than the crust, but not as dense as the core. So in other words, the core is more dense, and the reason why is because the volume is a lot lower. So the mantle is more dense than the crust, but not as dense as the core. The mantle is kind of getting hot. We're going from the crust and then down towards the core, which is the heat source. So you can imagine the temperatures in the mantle range from 600 degrees Celsius to 1200 degrees Celsius, and that transfers to about a little more than 1,000 degrees Fahrenheit to a little more than 2,000 degrees Fahrenheit. So pretty warm. To put it in comparison, the heat from the sun is about, the surface of the sun is about 10,000 degrees Fahrenheit. So we're not quite to the sun yet, but we're getting close. All right, so this is, I just kind of want to orient your understanding. The crust layer is at the top. Okay, then we have the mantle, and that mantle is actually that whole black space. I needed to make it not black. I couldn't make it orange. I had to make it the black. So that big section is the mantle. And then we've got the outer core, and the outer core is where we get our heat source, right? So if we've got magma, which is the melted rock, the molten rock inside the mantle, that is going to get hot. And as that magma heats up, it's going to rise. And as it rises, it's getting away from the heat source, so it's going to start to cool down. And then as the magma cools, it's going to sink to the outer core where it's going to start to warm up and rise and then cool down and fall. Now go ahead and take a picture of this and put it in your notes next to the other picture. There should be plenty of space in that white space in your notes that you can put both pictures. So this is called a convection current. And we talked a little bit about this. When you come back, if you need a little bit more clarification, I'm happy to help you. But the convection current, and this is the next section in your notes, a convection current takes place in the mantle, and this causes pieces of the crust to move. We talked a little bit about this last week, and I demonstrated if I have my arm flat like a plate, okay? And then underneath it, I'm going to use my finger to kind of show the rotation of the magma. When my finger comes up to the bottom of my arm, it's going to actually drag the plate in the same direction. And that's what causes the pieces of the crust to move. So you've got a picture here in the diagram of two oceanic plates that are moving away from each other because the convection current is moving them in that direction. And these are both oceanic plates or oceanic crust, and so they're more dense. So when they meet the continental plates, they're going to sink and they're going to go under the continental plates. And you'll see that if you track the convection current all the way around, you'll totally understand how that plate is moving from the right to the left, and then the one on the other side from the left to the right. Let me know if you're having trouble with this still. I want to make sure that you understand convection current. And then we ended our notes here. The mantle actually technically is made up of different layers too. They're called the lithosphere, which this is your vocabulary term. Litho means stone or rock, and sphere is globe. So the lithosphere is the rigid outer layer of the earth, which includes the crust and the uppermost part of the mantle, and it's divided into tectonic plates. So we don't have this really hard, distinct separation between the crust and the mantle. It sort of blurs itself right there because, remember, we've got this heat source coming from the core and it's going to the crust. And so there's this part of the crust that's sort of kind of in between molten rock and cooled hardened rock. So that's called the lithosphere. And then the second part is the asthenosphere. This is the weak or without, that's astheno. And sphere means globe. And so this is that mechanically weak. Imagine, the airhead, the kids were holding that out, and it was the warm one, and it just sort of bent down. You didn't have to push it or anything. It's mechanically weak. And in your definition, I put the word rigid, and I changed that today. I want you to put the word plastic, because we talked about plasticity, meaning that it can change shape. So I want you to have that same word, since we use that in the model. And this is where we stop today. Make sure, please, that you are spending some time reviewing your vocabulary, and hopefully I'll see you tomorrow.